Hello, once again. Um, we're going to discuss late adulthood briefly. You notice that the videos jump from early to late, and the reason I do that is because I leave you to look at and make your own judgments, etc., about middle adulthood. You're not there yet. I don't think we have any adult students in the class. I'm not sure um, that anybody would consider themselves middle adulthood in this class simply because the age ranges are different. Um, but you make that decision. I'm going to tell you in general that you probably consider yourself still early adults, even if you're 30. So uh, that's to come for you. Well, what all you're going to do in middle adulthood is increase your understanding that you begin to develop in early adulthood. So I want to jump to late adulthood. And I want to talk about some things. Sorry, my computer's giving me a fit. I want to jump to some things. I was going to say things that are shocking, but they really aren't. The Since the beginning of recorded history, this part is shocking. Since the beginning of recorded history, the maximum number of years an individual can live, get ready for this, is approximately 120 to 125 years. Does anybody live that long? Doubt it. We don't know. We don't know about people out in the middle of places where civilization hasn't, modern civilization hasn't gotten to yet. So I'm sure there might be somebody running around on the earth that's 125 years old. Who knows? But on average now, and these are relatively new figures, the average age of a human, your life years, 78.1 years. Females, and these are pretty recent figures. They may have changed in the last month or so. On the average, a female lives 80.7 years, males 75.4 years. Now, let me give you a little caveat. This is in general, okay? This is civilized cultures, and probably particularly westernized cultures, figures related to that. But guess what? The 21, 22, when COVID was banging around so bad, those figures went down. Now they're pretty much back up to where they used to be. So 120, 120, I don't want to live that long. Man, what kind of quality of life would you have? I'm 76 and I'm struggling now. Not too bad, but you know how it goes. Okay, so anyway, I hated my professors when they got personal. Okay, let's look at biological theories of aging, because that's what's important here. We all know people get old. Okay, well, we got some theories that address that. One's called the cellular clock theory. Cells can divide a maximum of 75 to 80 times. That's a lifespan. As we age, cells become less capable of dividing. Why do they die? Well, I'm going to give away an answer to one of your exam questions. Could be maybe to telomeres. What are telomeres? DNA sequences that cap the end of chromosomes, little end caps. Each time a cell divides, telomeres become shorter. After about 75 to 80 replications, telomeres are very reduced and the cell can no longer divide. So it's kind of like stretching a spring out, isn't it? Another theory, free radical theory. When cells metabolize energy, and a lot of people got into this stuff in the 80s, 90s, the byproducts include unstable oxygen molecules known as free radicals. And they travel around cells and they damage DNA and other cellular structures. So basically what's happening is you're deteriorating. Um, the mitochondrial theory. It's aging due to mitochondria. It's aging due to the decay of mitochondria due to oxidative damage and loss of, I'm going to call them critical micronutrients, the little stuff that your cells supply, food, if you want to call it that. And this process produces free radicals. Mitochondria become so inefficient that they can't generate enough energy to meet cellular needs. So again, this is a decay kind of theory. Memory, not to change the subject, but memory, there's a theory related to loss of memory called the decay theory. And all it is biological decay. And that's what I'm describing to you here. Hormonal stress theory. Aging in the hormonal system. That lowers resistance to stress. And it increases the likelihood of the disease. Stress it's horrible. Hans Selye did a lot of studies about stress. Distress will kill you, period, unless you do something about it. EU stress, that's good stuff. I just got back from a rugby workout just now. That's good stress. It's tough, but it's good for you. Good for me. I've been doing it since 1975, I think. So rugby training, that's eustress. A hormonal stress theory is related to distress, the bad stress, the emotional stress. Physical stress for you is, in many cases, is good. Emotional stress ain't. Emotional stress can kill you, period. So, with all that in mind, let's begin to wrap this short little deal up. I want to mention your brain. The aging brain. Your brain shrinks. You lose 5 to 10% of brain weight between the ages of 20 and 90. If you live to be 90. Volume decreases on average about 50%. From younger adulthood to older adulthood. And again, I apologize for my computer moving around. The theory or the hypothesis says that it may be due to a decrease in dendrites. These are little short branched extensions of a nerve cell. Neural impulses received from other cells at synapses. Synapses are junction between two nerve cells. I'm sure you had all that if you had biology. There are small little gaps across which impulses pass by diffusion of a neurotransmitter. Dopamine's a neurotransmitter. They're transmitted to the cell body. The prefrontal cortex, that's right here, shrinks. That's associated with working memory. When do you begin to lose memory? What age? I don't hear you. 25. Your memory begins to deteriorate at the age of 25. Doesn't mean by the time you're 25 and a half you don't know who you are. That would be Alzheimer's or dementia. So normal memory begins to decrease beginning at the age of 25. Intellectual coordination and intellectual performance decrease. Now, this is usually based over time. We're talking about normal here. We're not talking about disease or disorders, mainly disease. It's not pathological per se. Neurotransmitters begin to decrease. I mentioned dopamine as a neurotransmitter. Acetylcholine, ACP. Gamma, I don't know if I can still say it anymore. Gamma aminobutyric acid. You know what we call it? GABA, G-A-B-A. Now you know why. You won't hear many people running around saying gamma aminobutyric acid. Takes too long. Reduction in acetylcholine results in a small decline in memory function. So again, that's a neurotransmitter. You have a minor decline. Reduction in dopamine results in the decline of planning and carrying out motor activities. That's why you don't see people my age still playing rugby. Don't have those motor abilities anymore. Can't run fast enough. Can't kick the ball far enough, etc. And reduction in GABA results in less control of preciseness. One neuron signal sent to another. The preciseness begins to break down. You come kind of addled. There was an old term, addle-brained. Well, that's a lay term, but this is what they're talking about. So you begin to lose those functions. How can you battle that? How can you battle all this? Well, pat yourself on the back. You've taken the first step. Using your brain. Use it or lose it. That's an old saying. Well, it works in brains. Am I telling you that if you use your brain that you'll never lose any memory function? No, I'm not telling you that at all. What I'm telling you is use it or lose these functions you're going to lose anyway. You just slow it down quite a bit. So what's one way of doing it? Aerobic exercise. It increases brain volume in older adults. Yeah, pumping more oxygen up there. What's a good aerobic exercise? Walking. Yeah, not many old people can run, but walking's really good. It's probably the best exercise there is on earth. I'm serious. Walking and calisthenics, doing things like push-ups and junk. You'll hear weight people say, go in the weight room and lift all this stuff. Well, okay, if you're motivated to do that, go to the weight room and light weights, very, very, very light weights, very manageable. You're not trying to bulk up like Superman. You just want to keep things toned up and keep some strength. One of the major reasons people get old and start falling is because they begin to lose strength and coordination. They don't remain active. That's not a judgment call. That's factual science. Neurogenesis. It can occur in human beings, but in the hippocampus, in the memory area, and also in the olfactory area, smell. So, what am I telling you here? Your brain can adapt in that way. Now, do I have an exercise for that? No. Don't go around smelling everything to increase smell. But with exercise, you can make some gains. What does neurogenesis mean? Neuro, brain, right? Genesis, beginning. So you can actually help with that. Another thing called lateralization, specialization of a brain hemisphere function. As you age, your brain areas begin to share activities. Brains in young people your age, they function in a more lateralized way. They're not independent. Your brain is all connected. People say, well, I'm right-brained. Well, I feel sorry for you because the left side of your body don't work. Your brain is a network. There's specific areas on each side that do things, but you're not left or right-brained. That's like being left-handed or right-handed. Okay, well, we're left or right-handed, sure. But am I left brain and so my right hand is a lot better than my left? No. That's a big network up there. And then, as I say, some people are good at math. That's in one part of your brain. If you want to call that brain specialized, okay, but it's not completely correct. And then finally, at least for the moment, neurons. Older brains rewire themselves to compensate for losses, but not to the extent we'd like it to. If a neuron is not able to do its job, neighboring neurons may pick up the slack, but not always, and maybe not very efficiently. So it just depends on you as an individual as to what what occurs with your brain as you age. You probably all know that the that age affects the immune system. Um, Accounts for a lot of problems in older people. That's why you see all these COVID, for example, when that first came on the scene, people said, well, young children and old people. Young children's immune systems aren't as strong as you guys in this class, for example. And old people begin to lose immune system function. So that's something to look forward to. Stay in shape. Yeah, walk. That helps with that. And then physical appearance. Physical appearance and movement. Oh, my word. There's an elderly member of our family, and this is the honest truth. He's in his 80s. He wants to stay active, bless his heart. But he's lost a lot of coordination, and guess how many times he falls a week? At least twice. Thank goodness he doesn't get seriously injured. He's a farmer, and so he's a tough old bird, but he's gotten to his late 80s, now 86 I think he is, maybe pushing 87, and he's not going to stop. He walks with a cane, still goes and does his activities, doesn't farm anymore, but he still works in his shop and does stuff like that, drives a tractor. But he falls about twice a week, and he'll come home and have a thing on his head or elbows messed up or whatever the case is, and he laughs about it. So he knows it's old age. So movement becomes difficult. Physical appearance grows shorter. You actually lose height due to loss of bone and vertebrae mass. Once you get old, they'll send you for a bone mass scan or some junk like that. Hadn't been to one yet, not going. They want to see, they want to protect you against fractures and so on and so forth. I guess there are drugs they can give you for that. I don't know. Not taking those if I can help it. Weight loss due to loss of muscle. Guess when that begins to occur? 25. You lose weight. Now, of course, this is dependent on a lot of things. Exercise, diet, genetics. But only, we're talking average here. So, weight loss due to loss of muscle tissue. It's beginning at about the age of 25, and then, boy, time you're 75, you don't have nothing. How do you overcome these things? Exercise, exercise, exercise. Walking is the king. Light weight lifting, as I mentioned earlier. Lack of movement is going to cause the decline to increase, and then you get to a point where you can't walk distances. I'm not talking walking from the living room to the kitchen and back. Walking as in maybe 10,000 steps a day, or which is a popular figure for some reason. I guess they came up that with averages. But if you get to a point where you can't lift some kind of weight, like a coffee cup, or just joking, you need to be able to manage at least your own weight. I think I saw a thing the other day, when you're 75, maybe 70, you should be able to do 10 push-ups. In this country, I'm sure that would be difficult to find somebody that age that can do that, although I'm sure there's some out there. I'm one of them. Okay, so I can do 10 push-ups. Okay, so lack of movement. Don't quit moving, because that ain't good. Out to be done. Oops, sorry about that. Just about done. Okay, so we'll wrap up. you've heard about early. You've heard about it all. You've read about it all by this time, just about. We've discussed mainly mainly socio-emotional stuff, socio-cognitive stuff, some physical stuff, beginning in infancy right up to now we're old. And I think you most likely have a good working knowledge of this lifespan process, how it follows the vertical and the horizontal line. We're more concerned really with the horizontal because of the changes associated with it. So next video for the last week is going to be all about dying. That sounds like a big negative. We're not going to make it a negative. We're just going to discuss it. So be prepared for that, and hope this stuff wasn't too choppy. I like to do a little bit better job with these, but that's the way it goes. All right. Be with you soon.